Hi, and welcome back. In this video, we're going to talk all about inheritance, polymorphism, and the basics of using a package manager like Gradle. We'll talk about the differences between extend and implement, and a brief introduction to Gradle for dependency management and using log4j for logging. So let's first go over what is inheritance. Inheritance allows one class, the child or subclass of another class, to inherit the properties and methods of another class, or in other words, the parent or superclass. Think of it like a blueprint. A vehicle class might define common features you'd find on a car, like the amount of tires or the top speed, while subclasses or children of the parent class might inherit those features while adding their own details, like the number of doors. In the example below, we'll see how classes can inherit from their parents. So the parent or superclass here would be animal, and both bunny and dog are the children of the animal class, inheriting from animal. I think we should just go into IntelliJ and see how we can use inheritance. So I'm in IntelliJ here. Let's make a regular class called animal, just like we did in the last video. So I'm going to make a new Java class called animal, and I'm going to define just one method for it. Private void make sound, and I'm just going to say system.out.println I made a sound, semicolon. And so now let's see what the extend keyword does. So I'm going to make another class. I'm going to maybe call this dog, and then I'm going to, after this public class dog, do space extends out of animal. So now we have a public class dog that extends our animal object. And so now in here, let's define something like public int legs is equal to 4. And so now all we're doing is essentially we have our main animal class, which has a make sound method. So if we wanted to, we come to our main class here and make an animal is equal to new animal, and then just call animal dot, oh, I made this private, didn't I? I did, dot make sound, and as you'd expect, we're gonna see I made a sound when it runs down here. So yes, I made a sound, but what if I wanted to do a dog object? Well, I could do dog animal is equal to new dog, and then say animal dot legs, or I guess I'd have to system.out.println animal dot legs, and it's going to give us 4. But whenever we see this, we can also see animal dot make sound. It has the make sound method because dog is extending from animal, and animal has that make sound method. So if we wanted to do something like public void maybe sit down, why not? We can do system.out.println sit down, and we're also going to see animal.sit down. However, if we change this back to animal is equal to new animal, and we define something in here like public void stand up, we're not going to see this in here because we're going from the animal class, not the dog class. We could also just have the type here of animal and just make a new dog. That's also valid Java code because dog extends from animal. So there's actually 2 ways to inherit from a class. The most common one you use is extends, which as we know is used to inherit from a class, and the child class or subclass gets all the properties and methods from the parent class. But sometimes we don't want that, and we just want our class to implement a few methods from another class. And that's where we're going to want to use implements. Let's just go back into IntelliJ and see how we can use this. So I'm going to delete these animal and dog here, just as an example. And now we're going to go into new Java class. We're going to go down to interface instead of class. And maybe here we'll do animal again. Why not? Let me delete everything in the main method here. And so now in here, I can do something like public void make sound. And now we can make a new Java class called bunny, and we can implement animal, so implements animal. Now if we hover over this, we're going to see an error. Class bunny must either be declared abstract or implement abstract method make sound in animal. So let's implement the methods of make sound here and hit OK. And now we're going to see at override public void make sound. So what does this override method mean? Well, in our animal class, we already have a function defined to make sound. If we try to do this again, we're going to see an error because it's already defined. So to tell Java that we want this to be our own method that is the same thing as this, it just has a different output, we have to add the @override annotation, which annotations just have the @ symbol above them, and then we can just declare the method as usual, public void make sound. So in here, I can do system.out.println ribbit, there we go. And I could also copy this again with Control-C, Control-V on the class, do dog. So now, woof, woof. And now, in our main class, we can do animal is equal to a new bunny, just like we did earlier, and then say animal.makeSound. Let's copy this again for our dog, animal2, and make sound. We should see ribbit and ribbit. Why is that? Because we didn't declare animal2 here. So now if we run it, we're going to see ribbit and woof woof. So hopefully you can see the use of extends and implements. It's going to take a lot of time to get used to on which one you should use and why they're so important, but it's just good to know why they're there and how you can actually use them. So what is Gradle? Gradle is a build automation tool that's used to compile, build, and manage your dependencies in Java projects. It simplifies tasks like adding external libraries to your project. A lot of the time, you'll need external libraries in your project. Like when we build our client, one of the dependencies is going to be the actual Minecraft client. In this video, it's going to be the log4j for logging. Now don't be worried hearing the log4j name. It has a bad reputation in the Minecraft community with a vulnerability that was found a few years back, but millions of programs use it and it's really safe now. It's essentially like system.out.println, but a lot more expanded. Let's go into IntelliJ and see how we can use Gradle. So now if we go over to this website, logging.apache.org, we can scroll down a bit until we see, where is it? Installing log4j core. So we're going to click Gradle, and we're going to only copy over, or actually no, we can copy this whole thing. So we're going to copy this, we're going to go back into IntelliJ, and we're going to paste this down. We're going to see a few errors here, and that's just because we have to format it right. So we're going to replace these single quotes with double quotes, and then we're going to surround this whole string in parentheses, starting at runtime only. So now we can come over to this icon, which is Gradle and a refresh icon. If you don't see that, you can just go over to Gradle on the right-hand side and click refresh there. If it's giving you any errors, you can try going to the terminal and typing /gradle w clean and then just refreshing it again. And then instead of this runtime only, we have to switch this to compile only, and then we need to actually have one more thing here. So I'm going to go back to the website, and if we come back to this website, we're going to click on API over here, scroll down, we're going to go over to Introduction, click on Gradle again, and copy it, go back to IntelliJ, and paste it. We have to do the same thing just as we did with the one above. There we go. And then implementation is going to be fine here. And instead of this $log4j-api.version, we can just put in 2.24.3. And now let's refresh Gradle again. And now we shouldn't have any errors, but again, if you do, you can just type /gradle w clean, come back over here and refresh the dependencies. And that should clear it all up for you. So now going to our main.java class, below the public class main and above the public static void main, we can type private static final logger, the first letter capitalized, and choose here org.apache.logging.log4j. Then we'll put the logger name in capitals just because it's a final, so it's a constant, and constant name should be capitalized. Then equals to a log manager, again from org.apache.logging.log4j, .getlogger, semicolon. And now, down here, we can say logger with .info, I am logging a message, and semicolon. So if we run our file, so we actually have to switch this compile only back to runtime only. And now, under this resources folder, under the source folder, we have to create a new file named log4j2.xml and paste in this code. It'll be in the description. And so now, if we run our main.java Java file, we're going to see I am logging a message. So as you can see, this can maybe come in pretty useful cases than just using print line, because we can also do .warn, and it'll give us a warning here. Same thing, it'll also show us the time. We can also do an error if we wanted to, and many other things. Now for the challenge. I want you to make any type of game in the terminal. I'll leave this up to you how to interpret it, but some examples could be a higher or lower number guessing game, making a tic-tac-toe in the terminal, or even Connect 4. I'm going to give you a few seconds to pause the video before I moved on to what I created. So what I did is I created a simple tic-tac-toe game. The first thing I'm doing is defining a double array here with characters. So you might have not seen this before, but I'm creating an array basically inside of array. This is because I want both rows and columns. And so next I'm storing the current player as X, because there's X and O, and I'm storing a boolean if the game is 1. I'm then defining a scanner, and while the game is not 1 and the board is not full of X and O's, I'm going to print out the board. By printing out the board for each row and column, which is I and J, I'm just going to print out the board. And again, the board is up here, which currently is empty. Then I'm also going to print out little separators or pipes just to separate things out. And let's see. Next I'm saying player plus current player, integer move, row and column. I'm then accepting the row and column. And then if the row and the column, so where they're trying to access it, is currently empty or just a space, I'm going to modify that to be either X or O, whatever the current player is, and then I'm going to check if the game is 1. By doing that, I'm checking a check when function, which first checks all of the rows to see if they're 1 player. I'm then checking all of the columns, and then I'm checking diagonal. Next, I'm just flip-flopping the current player, and else, if it's not a valid move, for example, if it's already taken or it just doesn't exist, I'm going to print out this move is not valid. Then I'm going to reprint out the board so that I can update it. If the game's 1, I'm going to go ahead and say that player's 1, else I'm going to say it's a tie. So let's go ahead and see this in action. I'm going to run this now. And so the player X, I'm going to go the top left, so that's just going to be 0 space 0. And that's going to put X at the top left. Now O might want to go on row 2, column 1. So to do that, I'm going to say row 2, column 1. And remember, arrays start at 0, not 1. So to go top left, I'm having to do 0, 0. To go in the left middle, I'm having to do 1, 0, not 2, 0 actually. And so maybe X is trying to form a diagonal line. So that's going to be 1, 1. And now O is going to try and block that by going 2, 1. I actually miscalculated there, but now X has a freebie, so 2, 2. And now player X wins. So I hope you're able to get that, but that wraps up this Java crash course. I like to mention that this crash course can't cover everything, and that if you'd like to learn more about the language, which I highly recommend, I've linked a video in the description that's a comprehensive guide to learning Java for free. Learning more than what I've taught you in this crash course can only do you good, especially while you wait for the client series to come out if it hasn't already when you're watching this. The next coming weeks I'll put together a crash course for Kotlin. I made a poll the other day and an overwhelming majority of you decided you'd much rather the client be built in Kotlin instead of Java, and I couldn't agree more. Kotlin is much a more concise language than Java, while still allowing interoperability with Java, meaning all existing Java code is going to work just as fine with Kotlin code. I'll dive more into why we'll be using Kotlin in that crash course, and then we'll finally start working on our client. But for now, that's goodbye until then. You can probably expect that video to be out in about 2 weeks, since I'll be making it into one longer video.